Visually reading a class diagram, for instance, from the class diagram that we looked at before, we see that there are certain questions we can answer. Right? We look at the class diagram, we see the students, the sections, the courses, whatnot. We can answer questions such as, which students are enrolled in which sections, right? In which courses? That's certainly a question that we can answer. We can determine all the courses that a student has taken, all the students that are taught by a particular professor in what year. We can answer all those questions. These are the queries that we can answer. The average size of a section, right, for a particular course. Now, notice that we've gone from the class diagram to the type of questions we can answer, right? Usually it's backwards, right? Usually from the interviews that we've had with our clients, we'll discern the types of things that they want to know, how they want to use this database, what kind of questions they want to be able to answer from their data queries. Yes, and from those questions is what drives the design of the database. Everything starts from the requirements. What is it you want the database to do? That will drive the rest of the database design, all the constraints that you're going to impose, right? But anyway, these are the types of questions that we can query our database. And certainly there are certain things that we can't infer, right? We can't infer maybe the history of the students, if they've changed majors. We can't see if they've dropped out of a course or a section. There's no way to answer that. There's no history of any of that. So there's certain things that we can't answer. If that were part of the requirements, then it would be a different class diagram, right? We want to be able to track that kind of history, yes? But it was not in the requirements, so we never got to that class diagram. We do want to be able to do the conversion, going backwards and forwards between a class diagram, which is very conceptual, right? We want to be able to go into a more physical or lower representation into either JSON or Java or C#, or in our case, relational databases, right? How is that we're going to represent this in our tables? So first of all, we want to take a look at these relationships, right? These annotations, right, of the cardinality. We know that those things are going to eventually become foreign keys and primary keys. Yes, we can certainly start thinking about wherever you have a star, probably that's a foreign key, and wherever you have a 1, that's probably a primary key, right? So you can start looking ahead, perhaps in some kind of algorithm or some kind of set of steps and rules and heuristics that might drive how to convert this backwards and forwards into a relational database, right? Here from the UML to a relational database, or backwards, right? Certainly, each one of these classes will become a table, right? Students and enrollments and sections and courses, right? Plus all these ones and all these annotations will become foreign keys and primary keys. This one certainly says that there will be some primary key that determines which section, and that the enrollment having the star will have some foreign key that is referring to those section IDs, and that is referring to student IDs, referring to those primary keys in the student table, right? And over here, same thing, right? We have since we have a one-to-many, there has to be some foreign key on the left-hand side that is referring to some primary key on the right-hand side, and same thing between the department and the course. On the star side, probably have a foreign key that is referring to the primary key on the department. So we can start kind of like discerning a particular algorithm that we might use to convert these two worlds, might gap these two worlds, right? Obviously, these are foreign keys referring to those primary keys, right? Foreign keys to primary keys, right? And how they refer. Okay. So visually reading this, we looked at the things that we can discern, but there's also things that we can't answer from this diagram. We can't say, which students changed the major, right? Or if there's a professor advising any students, it's just not captured, right? It was never in the requirements. If we add additional annotations or additional relationships, maybe we could capture those kinds of questions.